So yeah, today we are going to talk about Ethereum staking and in particular the impact on proposed changes on how much reward stakers get. Important, this is joint work with Juan, Tan and Noe, and today I'm here with Nicolas, who will join me later. So what about staking? Here we go. So if we look today at Ethereum staking, roughly 30% of all ETHs that are available are staked in the Ethereum blockchain. This gives the staker a yield of around 3%. So the thing now is that the yield, this 3%, depends on the amount staked. And now there is concern that the yield is too attractive. So what's the exact concern? Basically that in the future, there will be almost all ETH staked into the ecosystem. So in this example, it's about 95%, and stakers still get a yield of 1.5%. Why is this a concern? So there are different stuff to consider, but the main, or one of the main points is basically the reason that staking is important for the security of the ecosystem, and if this is way over-secured. So 50% of staking would be sufficiently, or most believe this, to secure the network. It's not necessary to have 95% of ETH staked in the network. So the system gives away too much of rewards, which could spend it otherwise. There are other reasons, but this is one of the main reasons. So how can we solve this? Well, pretty easy, just reduce the rewards for stakers. And what does it mean? Basically, to reduce this reward, this issuance schedule, which defines how much reward you get for a certain amount of stake. Now the question is basically, when we reduce this curve, where will we end up exactly? Because this depends obviously how the stakers react to this change in rewards. And this is basically defined by this blue curve, which is the supply of the stakers, so to say. So this defines how they react to this change in rewards. Now that this is a solution, could be fine, but now there are concerns. So basically the question is, that could not only lead to the fact that the staking is reduced, here in this example to 50%, but it could also lead that the allocation of stakers will change. So basically that more centralized solutions gain more power, more decentralized solutions will lose power. And that's basically what we're looking at. How does this change in staking rewards change centralization? And for that, we are going to have a deep look at the blue curve, how it consists of, what does it consist. So let's start. When you look at the blue curve, we need to understand who does supply and how do they supply ETH for staking. There are basically three different possibilities, as you can see. One is solo staking. So you, as a staker, you can run your own validator, you run your own infrastructure and stake. So this is a very decentralized way to stake. Then there are others which uses intermediary, which most of you who are staking maybe use. So basically, you provide your ETH to a middleware that can be more decentralized. For Lido, for example, is one of the most famous examples. And then Lido basically stakes for you the ETH in the Ethereum protocol. Lido itself and others, they work together with other staking providers, as you can see in the figure. So these are, on the one hand, centralized staking providers, but Lido does not work with one, but like with 37, I think, or something like that. Rocket Pool works with more decentralized staking providers. And lastly, there are these big centralized exchanges like Coinbase, Binance, etc. They basically invest the stakes by themselves. So this is the most centralized solution. And now the question is, obviously, if you want to look at how this changes, how it is today. And as you can see, most of the stakes today are in this decentralized staking. Middleware solutions like Lido, Rocket Pool, is also in centralized exchanges, and only very few choose to solo stake. Now our question is, how does these numbers change if the rewards are reduced. And in particular also, we have a strong focus on solo stakers. Will this drive solo stakers out? For further purposes, we've simplified a little bit and just speak of these three categories. We have solo staking, decentralized staking, service providers, and lastly, centralized exchanges. So now, if you want to understand how this might change, we need to understand what drives stakers to choose one option or the other, or what are the benefits and drawbacks of different options. So basically, this blue line, try to take it out, so to have three different sectors for it. And most importantly, obviously, is the staking reward. How much do you get for it? But then, like secondly, also the costs, and they differ quite significantly between the different solutions. Solo staking, you need to invest in own infrastructure. Other options, you have to pay a fee. That's basically the cost as a staker, from the perspective of the staker. Then in addition, there are other reasons like additional yields. So for liquid staking, for example, staker can get additional yields by staking, which is not possible with solo staking. There are other reasons like revenue pooling goes in a similar direction with MEV. Maybe we come to that a little bit later. We have different risk structures. Solo stakers important to run their own net infrastructure, so to make sure that it works properly. Others have other risks. And lastly, different technology requirements, how to do it. So solo stakings, you need to understand how to stake, how to run a validator. At a centralized exchange, everybody can do that. So there are different requirements to do that. All of them, okay, first point here, like the difficult part of it is that all of them are connected over the staking reward, but this depends, is the same for all different solutions. So there is an independency between those. So, yes. Now, as I said before, like all these three options, when we add them together, we get basically to this staking supply. And now to learn more about how this could change if rewards are changed, we try to formalize it, basically using an economic model. That's where Niki will come into place.
Perfect. Thank you, Matthias. So as Matthias mentioned, we want to kind of develop a simple model, economic model, to guide kind of, or to gain some intuitions behind how these staking decisions might be formed, and especially how they might be affected by changes in the staking yield. So firstly, what we do is we assume a segregated staking market. So we assume we have three types of stakers that each individually stake via different staking solutions respectively. So we have a retailer, for example, that only stakes via a centralized exchange. And this is the distinct market to, for example, techies that only stake via a decentralized staking service provider like Lido. And what we then assume is that these agents, they set their optimal staking amount in order to maximize their profits, and they do so strategically, so they take into account the other agents' staking decisions. And in terms of profits, obviously profits, they consist of revenues and costs. In terms of cost, we consider this issuance yield, so this curve that Matthias showed you in the outset. But we also consider two other sources of external yield, so in particular MEV, and kind of like DeFi yields that stakers can earn when they, for example, reinvest a liquid staking token that's being issued by some of these decentralized staking service providers. And then in terms of costs, we simply assume like a generic cost function that differs across different staking methods. So from the perspective of a staker, as Matthias already provided some intuition about, the cost function for a staker to stake via one method differs from another method, okay? And the goal we have in developing this kind of simple model is first we want to kind of understand how these model parameters affect how stakers would change their staking supply in response to a change in yield. And then in a second step, we run some calibration exercises where we set model parameters and then we explicitly compare these model equilibria, or the equilibria outcomes, across two different issuance schedules. Okay. So first, I think we have three intuitions or three observations that we can make based on this model that I think are useful and we want to share with you today. The first one is regarding these variable costs, okay? So what we find, or what this model will predict, is that if variable costs are high, then a staker would adjust his staking supply by less in response to a change in the staking yield compared to a staker that faces lower variable costs. So if we imagine the overall staking market, if we assume that we reduce issuance yield and we hold everything else constant, we would expect the decline in total amount staked to be larger for those staking solutions where stakers face lower variable costs. And then a second observation we can make is similar, but it regards these kind of external yields, these MEV and DeFi yields that are available for some staking solutions. And here we see a similar effect. So if DeFi yields or these external sources of yield are higher, or stakers have access to these sources of yield, then we would expect their adjustment in their amount staked in response to a change in the issuance yield to be smaller compared to a staker that doesn't have access to these DeFi yields or these external sources of yield. So again, if we imagine the overall staking market, we could again imagine, okay, if we reduce the issuance yield, you would expect a disproportionate decline in staking supply for those staking solutions that don't offer these kind of additional sources of yield. And then a further observation that we think is somewhat interesting in the context of this model is regarding fixed costs and profitability. So we find, or the model would predict, that if fixed costs are high for staking, then a change in the amount staked leads to a disproportionate change in the profitability of staking compared to when fixed costs are low. Okay? So again, in the overall staking market, if we assume that the total amount staked declines, you would expect the profitability or the overall profits to concentrate among staking solutions that don't have high fixed costs. Okay? So it's kind of a comparative result. Okay, so these are kind of the intuitions that we think are useful. And then, as I mentioned, we do some calibration exercises. These aren't necessarily meant to yield explicit predictions, but we think if we kind of make some useful assumptions, then it might have some interesting insight. So again, we're showing you one of these where we think we're making reasonable assumptions. And here, regarding the cost function, we make three assumptions, basically. So we assume that this fixed cost parameter, capital C, is highest for solo stakers compared to decentralized staking service providers and centralized exchanges. So this just in effect means, as Matthias mentioned, if you're solo staking, you have setup costs, you have hardware costs, all of which you don't necessarily have when you just depositing your assets in a centralized exchange, basically. And then a second point is this alpha parameter, which we also assume to be largest for solo stakers. And here we assume that, okay, when you're scaling up your solo staking operation, at some point you're having to expend additional labor resources just to make sure that your staking operation is running smoothly and that you're, for example, minimizing your validator downtimes. And this isn't necessarily the case for other solutions. When you stake via centralized exchange, from the perspective of the staker, this is basically done for you. Okay, you can scale up, you can add as many assets as you want. Basically, you're not having to expend any more labor resources, basically, or operational costs. And then finally, we assume that this small c variable cost parameter is higher for these centralized exchanges and decentralized service providers, just because there you pay fees, and if you solo stake, you don't have any fees. Okay. And then, as I said, we calibrate this model according to these assumptions, and we kind of compare the equilibria across these two issuance curves. The first one is the one that's being implemented in the protocol today, and the other one is a popular suggestion that's being discussed in the community. And what we find here is that when we compare equilibria outcomes, is that at least in the short term, or just if we compare the two equilibria, solo stakers adjust their stake by less than the other staking solutions, okay, when we shift from today's issuance curve to the proposed issuance schedule. But at the same time, we also see that profits from staking from the perspective of the ETH holders, they consolidate among DSSPs and CEX users. Okay, so because of these higher fixed costs that solo stakers face, solo staking, when the issuance is reduced, becomes disproportionately less profitable compared to the other types of staking solutions. Okay, and when we kind of expand our horizon beyond the model, and maybe also kind of relax this assumption about the segregated staking markets, we can make some conjectures about possible long run effects. So again, because of this reduction in profitability that solo stakers experience, we might see that, okay, in the long run, these solo stakers are driven out of the market, either because profits are accumulated in the other solutions and reinvested to a larger degree and kind of accumulate, so a larger asset base accumulates over time in these other solutions, or simply you could find that, okay, some solo stakers, because there's additional loss in profitability, they switch to other kind of staking solutions. Again, this is just a calibration exercise. We're not. I think we argue that this is based on reasonable assumptions, but again, at this point, there's no empirical backing here. So this is just basically a thought exercise based on reasonable assumptions. So what we also did is we tried to do some empirical research to try to kind of calibrate to gain some evidence to back up our model calibration. And what we did there is we tried to estimate the shape of the supply curves basically for different types of stakers. So what we're doing is we're basically estimating the yield elasticity of supply. And econometrics, the common method or a popular method to do this being used in econometrics is the instrumental variable approach, which basically just uses variation or exogenous variation in the demand curve to identify, to kind of trace the supply curve. Okay, and for this you need instruments. We try out several different instruments. We use past EIPs and gas fees as instruments, which one could possibly argue are kind of represent exogenous shifts in the demand curve, but don't necessarily affect the supply curve. Okay, and what we find is that at the moment we find conflicting results depending on which instrument is being used. Okay, so either our estimation approach, our instruments are not very robust, or we need to use better data. But I think at this point, whether or not this intuition we developed before can be supported by actual empirical observation is still an open question here. In any case, maybe to just summarize, so Matthias motivated in the outset, okay, there's ever-increasing amount being staked currently in the Ethereum ecosystem, and because of this, people have started discussing reducing issuance yields. And the question we ask here, or we asked in the research we presented now, is that, okay, maybe this reduction in issuance could yield additional risk, so concentration of assets in staking solutions that aren't necessarily beneficial to the network. Okay, and what we find based on this theoretical model is that, okay, if we reduce issuance, this could drive out smaller solo stakers, or especially smaller solo stakers that distribute their fixed costs basically across fewer invested assets. And of course, we also see, because this profitability shifts disproportionately, we also could see an increased demand in relative terms for solutions that offer this kind of additional sources of yield, so MEV DeFi yields. Of course, this is only preliminary results, basically. So as I mentioned before, there's certainly further research to be done on this topic, I think. I think there's no definitive answers yet in the community. One thing that certainly needs to be done is improving the data, making sure that we have empirical estimations to calibrate our models. And then, obviously, this model is a simple model. It could be expanded by several relevant dimensions. One of these is potentially to introduce like an intermediary market and allow kind of these staking intermediaries like Lido to dynamically set fees and see how this changes the equilibrium outcomes. And then finally, you could also, another important aspect would be to kind of consider other EIPs that are being discussed currently and how they would affect these outcomes, or how they would affect how stakers adjust their supply in response to change in yield. So here we're thinking about things like MEV burn, higher maximum effective balance, these kinds of things. So much to be done. But thank you for listening.
Thank you. Thank you.